So, you're looking for a new 3D printer, but the ones out there don't quite fit what you need. Why not build your 3D printer from scratch? In this video, we'll cover the details on how to build a 3D printer. Let's start by talking about frames and motion systems. Here at MechMinds Hub, where knowledge and mechanics combine. Without further ado, let's get started. Understanding your printer, Cartesian bed slinger variant. First things first, you need to decide the type of printer you want to build. For now, let's focus on the Cartesian bed slinger variant, using the popular Ender 3 as an example. The Ender 3 is a budget-friendly 3D printer that has been numerous iterations. Despite the variations, the core design, known as Cartesian motion, has remained unchanged. This design involves movement on 3 planes, left and right, x-axis, back and forth, y-axis, and up and down, z-axis. The Cartesian motion system relies on a belt-driven setup with roller bearings for traction. These roller bearings, often with V-slot grooves, move along aluminum profiles. The simplicity and cost-effectiveness of this design make it a staple for budget-friendly printers. The Ender 3's frame, for instance, consists of various aluminum profiles, with thicker ones at the base for stability. Choosing the right aluminum profiles. The choice of aluminum profiles is crucial. Thicker profiles at the base and columns ensure rigidity and a low center of gravity, minimizing vibrations. The profiles typically have V-slot grooves compatible with roller bearings. Ensure you get the right profiles for your printer, considering factors like weight and intended use. Aluminum profiles also come with internal bores, allowing for easy threading. However, be mindful of the profile's compatibility with roller bearings. Some profiles have square bores, requiring corner brackets for attachment. It's essential to match the profiles with the chosen motion system. Motion system, pulleys, belts, and bearings. The motion system of Cartesian printers relies on pulleys and belts. The Ender 3, for example, uses a 2GT belt. The choice between GT and GT2 depends on the tooth profile, with both serving a similar purpose. These belts, typically made of rubber or polyurethane with a steel wire skeleton, facilitate movement in the X, Y, and Z axis. Linear bearings or roller bearings play a crucial role in the motion system. Roller bearings are cost-effective and well-suited for budget printers, while linear bearings are more compact but pricier. Properly aligning these bearings with aluminum profiles is essential for smooth operation. Understanding the Cartesian printer landscape. Despite the Ender 3's popularity, there are numerous variants with added features like BL Touch, Direct Drive, or all-metal hot ends. However, the fundamental Cartesian motion system remains unchanged. While this design is reliable and easy to work with, it might lack the excitement of more innovative printers. Exploring other printer types, Delta and Core XY. Moving beyond Cartesian printers, Delta printers offer a unique approach, using 3 motors to control the X, Y, and Z axis simultaneously. Deltas provide increased stability and speed. However, their complexity and limited part compatibility can be drawbacks. Core XY printers, on the other hand, combine features of both Cartesian and Delta systems. Motors work in tandem for greater speed and stability. Although becoming more popular, Cartesian printers still dominate the budget-friendly market. Introducing your design, Core XY printers. Now, let's delve into designing your 3D printer. We'll consider a Core XY setup, aiming for a budget-conscious small printer and a larger, less budget-conscious version. The smaller printer will feature a 3D printed frame, linear guide bearings, and integrated components. Linear rails, despite being pricier, offer a more compact and minimalist design compared to linear bearings. For the smaller printer, the frame itself will be a 3D printed, showcasing a trend seen in some earlier models like the Tantalus. This approach is experimental and aims to demonstrate the potential of modern technology and materials in 3D printing. For the larger printer, linear rails and aluminum profiles will provide stability and precision. The combination of rails and profiles allows for robust construction suitable for larger print volumes. Materials matter. Choosing filaments. When 3D printing the components, material choice is critical. While ABS is commonly used for its strength and flexibility, PLA is more brittle and may not be the best choice. PETG or PCTG can serve as alternatives to ABS. For the smaller printer, a personal choice is made with PETG carbon fiber for its strength and texture. Troubleshooting and tips for building your 3D printer. As you start on the journey of building your 3D printer, it's essential to be prepared for potential challenges. Troubleshooting is a significant aspect of any DIY project, and 3D printing is no exception. Let's explore some common issues you might encounter and tips on overcoming them. Calibration challenges. Calibrating your 3D printer is a crucial step to ensure accurate and precise prints. Issues like bed leveling, nozzle height, and overall printer calibration can be challenging for beginners. To simplify this process, invest time in understanding your printer's firmware settings and utilize tools like bed leveling sensors for added accuracy. Print quality optimization. Achieving high-quality prints requires fine-tuning various settings. Experiment with layer heights, print speeds, and temperature settings to find the optimal configuration for your specific 3D printer and chosen filament. Additionally, understanding the impact of cooling on your prints and optimizing fan settings can significantly enhance print quality. Upgrading and modifying your printer. Part of the beauty of building your 3D printer is the ability to customize and upgrade components. Explore options for adding features like auto bed leveling, direct drive extruders, or upgraded hot ends. Upgrades can enhance performance, reliability, and the overall capabilities of your printer. Choosing the right power supply. The power supply is a critical component often overlooked by beginners. Ensure your 3D printer has a stable power supply to avoid issues like layer shifting, print failures, or damage to electronics. Opt for a power supply with adequate voltage and current ratings, and consider using a quality surge protector for added safety. Optimizing print speeds. Print speed is a crucial factor influencing both the efficiency and quality of your prints. Experiment with different print speeds for different components of your models. While faster print speeds can save time, excessively high speeds may lead to inaccuracies or layer adhesion problems. Finding the right balance is key to successful 3D printing. Expanding your 3D printing knowledge. As you dive into the 3D printing world, go beyond just building and designing printers. Explore advanced areas like experimenting with different 3D printing materials such as flexible or composite filaments to add strength and intricate details to your prints. Expand your skills by not only focusing on the printing process, but also learning post-processing techniques like sanding, painting, or using smoothing agents to enhance the visual appeal of your creations. To truly enhance your 3D printing abilities, concentrate on improving your computer-aided design or CAD skills. Learn how to craft detailed models, optimize designs for 3D printing, and troubleshoot common design challenges using CAD software, suitable for your skill level. Community engagement. Joining 3D printing communities and forums can provide valuable insights, troubleshooting assistance, and a platform to share your experiences. Engaging with the 3D printing community opens up opportunities to learn from others, exchange ideas, and stay updated on the latest trends and technologies. Building your 3D printer is not just a technical task, but a journey of exploration, learning, and creativity. By understanding different printer types, solving common issues, and going beyond the basics, you empower yourself to craft unique objects with precision. As you advance in your 3D printing journey, view every challenge as a chance to learn and enhance your skills. Embrace the iterative process and feel free to experiment with new ideas. Whether you follow a specific design or explore uncharted territory, the world of 3D printing is open to your innovation. There you have it! Familiarizing yourself with 3D printing and embarking on a journey of building a printer from scratch can be an immensely rewarding endeavor. If you want to share your experiences, feel free to leave your comments below. Don't forget to hit the subscribe button for more videos like this. Thanks for watching and see you next time.